Alright, now that we have A star fully functional and easily usable by any of our code, it's time to revisit the behavior system. It is now time to make actors aware of and able to use the navigation network. So what we're going to do is we are going to build an actor behavior that utilizes the A star navigation. This is going to be called the behavior nav. So at the end of this video, we will have a new behavior class that takes in a path, generally a path generated by A star's findPath method, and simply navigates from the beginning to the end of that path. So to get started, let's go over to navigation and add a new class. This class is of course going to be called behavior nav. Behavior nav. We'll add this class in place, clean up the sub namespace. We need to add in a using statement, so we'll add a using for Microsoft.xna.framework. And the class itself, of course, needs to extend behavior. Alright, now that this is officially a behavior class, it's time to start fleshing it out. We'll begin at the very top with some fields. There are some things we'll need to keep in mind as we are updating. We also need to hold a reference to the path itself, since the behavior is actually recalled every time an update occurs. So the first thing we need to hold is an integer saying where we are currently at in the path. We are going to call this integer node index, and we will explicitly initialize it to 0. The next thing that we'll need to hold in between updates is the current path being navigated. This will be a list of node that is simply called path. Alright, that takes care of our fields for holding state information. Now there's one more field I want to add. With this behavior nav, it would be very useful if the behavior itself could cause an alert or alert other code when the path navigation finishes. It'd be nice to be able to tell when the actor finishes and arrives at the destination node. So we're going to put together an event that will get fired the moment the path navigation finishes. So what we'll do is we will make a public event of type event handler, and we're going to call this event goal reached. Now, as we had done earlier in the input handling classes, we're going to assign an anonymous method to this delegate to make it immediately callable later in our code. So we will say that goal reached is equal to delegate. Now we need to pass in a method signature satisfying the event handler, which is going to be object called sender, and an event args, which we will call E. So we'll finish up the method signature and place braces out to the side to finish off our anonymous method, and then terminate to finish off the creation of the goal reached event. One other thing I'll note is that we're using the standard event handler in this case instead of defining our own delegate, simply because I'm not worried about the information returned by goal reach. All I want to see is the event itself taking place. So rather than creating a delegate that takes in an empty signature, I decided to simply use the already existing event handler. Alright, now we can move into the methods that are part of the behavior itself, beginning with the constructor. Of course, we need to have a constructor that's going to take in a weight in order to properly initialize the behavior. So we are going to make a public constructor. In this case, it means public behavior nav. And we are going to take in a float parameter called weight. Then we will also chain to the base constructor, where we will pass the weight parameter along. And now I'll place the method body just out to the side, since there is nothing further that we'll need to set up inside of the constructor. Alright, now the way that this behavior is going to work is slightly different from some of the past behaviors. Rather than having it take effect immediately, we're going to wait until an additional method is called. This is going to be done in order to make the behavior itself more reusable. One of the options we would have would be to pass the path in directly using the constructor, and that way we could have navigation begin immediately upon creating the behavior. The problem with this is the moment the path goal is reached, we're done with the behavior. Once we reach the goal, there's nothing else for it to do. And that would mean we would run into a scenario that is going to end rather than continue indefinitely. So what we'll do is we'll separate the idea, and we'll have a separate method entirely to take in a path and begin navigation. That way, a single behavior nav instance can be reused to navigate a different path at a future point in time. So let's put a method together that will begin navigation. We'll make a public void method called begin navigation. And this method is going to take in the path that we need to navigate. So we'll take in a parameter that is a list of type node, which we will call path. Then we can block in our method body and begin setting up what we'll need to do to reflect the fact that we should now be navigating. What we'll do is we'll make sure that node index gets reset to 0, just in case this is on the second or so on call of the behavior itself. We'll make sure that node index gets set back to the beginning. Next, we'll make sure that we remember the path that was passed in by setting this.path to the path parameter. Alright, that's all we need to do in order to begin our navigation. Now we need to code in the update method for the behavior nav class. We'll make a public override to the update method. Here we will not worry about calling base.update, so we will erase our call to base.update. And we need to begin here with a check. Inside of update, we're going to make sure that 1, we do in fact have a path, and that we're not already at the end of the path before we start attempting to use that path to influence the motion of our actor. So this check will be if path is not equal to null, and if node index is less than path.count. So only if we have a path and are not at the end of that path will we start using that path. Now, if we found that we do have a path that we need to continue navigating, what we'll need to do is calculate the node that we should be going to. Of course, in calculating the direction, it would be very easy to get our direction from one node to another, or from ourselves to another node. But we do need to make sure that we navigate node to node, meaning we navigate to the first node. Then we have to have a condition that detects that we have reached the first node so that we can advance to the second node to the third node, and so on. So what we'll do to make things a little bit easier is we'll make a local variable here called next node to basically tell us that this is the node of interest and the node we're trying to get to. So we will make a node called next node. Now, next node is simply going to be the node in path that is currently pointed to by the node index. So we will address path sub node index. And again, this just gives us a more convenient name to work with as next node. Alright, now we need to do a check and see if we have arrived at this node. So what we'll do is a check very similar to a radius-based collision check. We'll see that if us, as an actor, have distance-wise collided with the next node, if we have, then we'll consider that we have reached the next node and advance past it. So what we'll do is we'll say if vector2.distance between actor.position and next node.position is less than next node.radius. Essentially, if we are inside of that node's radius. So if this is indeed true, then we will say that we have reached that node and we need to advance. Now we'll advance by simply taking node index and incrementing it. So node index plus plus. Now that we have advanced the node index, we need to see if we have reached the end of the path or not. So we'll do a check and say if node index is equal to path.count, then we've actually set node index to be one item past the end of the path. So we definitely don't want to try navigating there, since this would be out of bounds to the path list. So if if node index has just been advanced past the end of the path, that means we have reached our goal. So we are going to fire off the goal reached event. Now, of course, since we're using the standard event handler delegate, we'll need to satisfy the object and event arg's signature. For object sender, that's simple enough to gather, as we can simply pass our current instance of the behavior navigation. For event args, there's no further information that we want to pass along, so we will simply pass event args.empty. Alright, once we've made this call to our event, we are going to return. Because at this point, one of two things has happened. One, we can either wait till the next iteration around to begin moving towards the newly assigned node, or if we have indeed reached the goal, we don't want to change the direction at all, because if we try to use node index at this point, we've looked past the end of the chain and we're done navigating. Alright, now if we have not collided with a node, then we need to continue navigating to that node. So we'll calculate a target direction between the actor and the node that it's trying to reach. So we'll make a vector2 called target direction, and we'll set this to be equal to next node dot position minus actor dot position. Now we want to normalize this vector to make it into a unit vector, but of course we need to check and make sure that it's not 0 before we attempt to normalize. So we will say if target direction is not equal to vector2.0. Then we know that we do have some magnitude and we can normalize. So target direction, we'll simply invoke the normalize method, and that will take care of normalizing our vector. Now that we have a unit vector, we can use that vector to influence the direction of our actor. So actor.direction plus equals target direction times this dot weight. Alright, with all of this in place now, we can see that we have no further syntax errors. We can build to make sure that this behavior class gets saved out, and we have now fully assembled a behavior that can be used on any actor that will allow that actor to navigate the path node network. So with this in place, that's going to bring this video to a close.